Hopefully this will be all right. That's what the graphs look like.
Yeah.
Sketch the graphs. Just put them in your graphical calculator. Do that for all of them.
Okay.
So let's see. I'm just going to use this sine graph. How could you use this graph to get two more values that work? Sine of minus 30 is minus a half. So you need two more values. So minus 30 is probably about there.
Yeah.
And that is minus a half. Sure is. And so we want two more values with the same sign. And so what would those be?
You do positive 30, would that work?
Nope. Positive 30 is up here. It's plus a half. It's where it's the x coordinates of the points of intersection of the sine graph with y equals minus a half.
So could you do 210 degrees?
So that looks like 210 to me. 180 plus 30.
Mm-hmm.
And one more.
330 degrees.
Yeah. That's fine. It's a difficult way of going about it. They went negative. Do I have the negative side? Yeah, we could have gone negative. We could have gone this way. That'd be minus 150. Fair enough. Fair enough. Sketch graphs. What is this? Y equals. All right, you just use a graphical calculator.
Yeah.
Yep. What is this? Use your graphical calculator. Just do y equals 1 over root 2. I don't like these questions. That was easy. Okay. Sketch these graphs. Graphical calculator. If we and let me just show you something.
Okay.
That might be helpful. Let's open this up. You can actually limit it. So I'll show you the kind of normal way first, and I'll show you cheat way. Oops. I'll make it bigger in a second.
Okay.
I'll just get it up first. So this is 3. I'll go with 3 sine x. So 5 for graph, 3 sine x. And so, okay, so I need to do shift view window standard, maybe? Oh no, trig, great. Equals, great. So let me just make that a bit. Calc screen, normal. Oh, wrong one. Calc screen, normal. I think I should zoom out a bit or something. That's the view window. Zoom auto. Hey, that looks a bit better. So if I keep pressing right, this thing is going to go on forever and ever and ever.
Yeah.
And so exit. I go back up to my thing, press left to edit it. You have a comma over the delete button. So comma, shift plus gives you a square bracket. And we can actually put in minus. Oh, I don't know how to put in. Yes, I do. 180 degrees is pi. Hopefully that will work. What is pi though? View. I have to get rid of these toolbars. It's roughly 3.14. Get rid of those. And so minus. So from shift pi. So from minus pi, comma, to pi, comma. Oh, I pressed the wrong one. Shift that thing for pi. Yeah.
Yeah.
And then shift minus for close right bracket. Press equals, oh, shift. I don't know, view window. Trig. Oh, it's in degrees. Are you in degree? Calculator? I didn't know you did that. So I can just do 180. Because it changed it into trig. I wish GeoGebra could do this. There we go. And maybe shift zoom auto. Great. And so you can even, it looks like it goes up to 3 down to -3. Yep, that's what it looks like. There you go. And so you don't even have to kind of think about, like, it would stop at 180 and start at 180 or whatever. You can just put the whole thing in. I don't want to, yeah, that's what it looks like. Oh, I did 3, I should have done 0 to 360 for, I mixed and matched. Yeah, it's okay.
Yeah.
You get the idea. Okay, so they get weird. A half plus cos x, it's all the same to the calculator. Tan theta plus 45, cos theta minus 90, just x minus 90. You're literally just putting it in the calculator. So they get weird. Cos, you know, you could do x over 3 from minus 540 to plus 540. It's just...
Yeah.
So now that they're asking about transformations. So this is the stuff. Why didn't they ask this earlier? I'll see what you already know. Let's see what you already know. So y equals sine x becomes y equals 3 sine x. Any idea what the transformation is?
Does it go like up or down like 3 levels?
Yeah. Any idea what that transformation is called?
No.
If it's multiplied, it's a stretch.
Okay.
Scale factor of 3, and it went up and down, so it's in the y direction.
Yeah.
Is that familiar?
No. I know scale factor, but not stretch. But I know y direction, but not stretch.
We need to do something else then. Algebra. Transformations of functions. Let's go with this one. This is difficult stuff, I tell you. Difficult. Hey, we got one for free. Okay, let's do these two.
Would it be a 4-2?
Well done. Other one.
Minus 3-2.
Yep. Minus 3, 2. Okay. What is this one? 1a.
So is x2 then?
Yep.
Okay. 7.
Yep. How about 2a part 1?
Okay. 19.
Very good. Very, very good. Okay. Solve. F of x equals 0. This equals 0. What is x?
Minus 2 or 3.
Nope. Other way around.
Plus 2 and minus 3.
Yeah, so it's like x minus 2 equals 0 or x plus 3 equals 0.
Yep.
X equals 2 or minus 3. Find the f of x plus 7. That would be, you replace x with x plus 7.
Yeah.
X equals 2. Let me do that better. You'll see why. 2 minus 3. And so x plus 7 equals 2, or x plus 7 equals minus 3. Solve these two.
Would the first one be -5?
Yep.
The other one would be -6. Oh no, sorry. -10.
Spot the difference. What 2 became -5, -3 became -10. What happened to it each time? What makes 2 become -5? What makes -3 become -10?
2 becomes -5 when when -7's added on.
Yep. And so essentially, we did the f of x plus 7.
Yeah.
But that did -7 to the x's because we bring it across to the other side.
Yeah.
Now let's try. Let's try f of x -1. And so it was x equals 2. It becomes x x -1 equals 2. Or x -1 equals -3.
So x is 3. Our x is -2.
Yes. And so what did the f of x -1 do to both answers? 2 became 3.
So it added 1.
Yes. The f of x plus 7 subtracts 7. The f of x -1 subtracts 1. And so the f of x plus a subtracts a. So it's always the opposite sign because you have to bring it across the equal sign.
Yeah.
Second. This one.
Okay.
So the 0.35, where is that after y is equal to the f of x is transformed into y is equal to the f of x plus 3?
Wait, so would we wait? So do you have to substitute 3 in or something?
What is the x coordinate for this one?
3.
So x equals 3. It becomes x plus 3 equals 3.
So it would be 0. So x is 0.
And so full coordinate?
0, 5.
Well done. How about this one down here?
Okay.
I tell you what. See, I haven't. Let me come back to that for a second. No, yeah, I have to do it. Okay, so f of x plus 3 moved it 3 to the left. So 0, 5 is here.
Yeah.
and so it'd look like that. So now let me go back. Let's try these. And so move. So the question A, so each of these is y equals the f of x. Move this one, y equals f of x minus 1. What way will that move?
Down 1.
That would be if the minus 1 was outside the bracket, it would affect the y direction. It's inside the bracket next to the x, so it affects.
Would it move left 1?
It would be right 1, because it's
Okay.
always the reverse.
So would B be down 2?
So 1 second. If I was to rearrange the B, they already brought it over to the other side of the equal sign.
Yeah.
See what I mean? And
Yeah.
so that would actually be plus 2, because they already moved it to the other side of the equal sign. And so how about the last one? What's the vector for that one?
Minus 1, minus 1.
Very good. Very, very good. And so is there, let's see. Okay, let's try this.
Okay. So would A just move down 1? Up 1, sorry.
Yeah, so the whole graph just moves up by 1. B?
Down 2.
Yeah, so I think I'll write that as like that.
Yeah.
C?
Minus 2, 0.
Yes, so maybe I'll just sketch at least one. Okay, that's minus 2, 0. And last one?
4, 0.
4, 0. Yes. Here we are adding and subtracting. Plus 1, minus 2, plus 2. That's called a translation.
Yeah.
The graph just slides. Yeah, you killed it. You killed it. Okay, working in reverse. These were, let's just call each of these, well, they were y equals x squared, which we'll just call y equals the f of x.
Okay.
And so what is the equation of the first one, given that it used to be at 0, 0? They all started from 0, 0.
Y equals fx minus 1.
Well done. Let me just see. Okay, question B.
Y equals fx plus 1.
Question D.
Y equals fx close brackets plus minus 1.
Yeah. How about question F?
Y equals fx minus 2 and then minus 1.
Perfect. And if they asked, what if they said for F, they said describe the transformation? What would you say?
The graph moved in the transformation.
It sounds like
plus 2 minus 1.
So 2 minus 1. It sounds like transformation. What's the specific transformation?
Translation, sorry.
Yeah, translation. So it's a translation by the vector 2 minus 1.
Yeah.
You destroyed those. Trig graphs, we better do... No. It's just... when they're not weird, we'll do them. It's just because that was the ones that we were looking at. Yeah, how about these? Yeah.
So would it be a sine graph?
Describe the single transformation.
the whole graph would move
Describe.
1 unit. Oh, would it just be 1, 0?
That is no, that would be if you're thinking of if it's in the bracket next to the x.
Oh, so it's out of the bracket. So
Yeah.
it's just 0, 1.
0, 1. What type of transformation is it? Name the transformation.
It's a translation on the y-axis.
It's a translation
Oh, okay.
because it has plus or minus. It was adding or subtracting. Translation and by the vector 0, 1. But I think just translation 0, 1 is enough. And this one down here.
That'd be it would move to the right by 90 degrees.
Describe the transformation.
Translation by the degree?
No. Translation by the vector.
Oh, by the vector 90, 0.
Yeah, and maybe I'll put 90 degrees, but yeah. That's where the degrees would go. Fine. So we did trig. Okay. How about this one?
So would it move up by 2? So go to 2.
Yep.
And then you sketch the same graph.
Part B, describe the transformation.
Translation by the vector 0, 2.
Great. Fine. This one. X equals 3 or x equals minus 2. And so the f of x, f of minus x, it becomes, hang on, it was originally x equals 3 or x equals minus 2. It becomes minus x equals 3 or minus x equals minus 2. And so solve each of those.
Okay. So does it become x equals minus 3 and x equals 2?
Yeah. If you had a number line, you have 3, 2, you have minus 3, minus 2. So the one that was on 3 moved to minus 3. The one that was on 2 moved to minus 2. What type of transformation is that?
It's a translation.
No. Because that one is 6 and that one is 4.
Reflection.
That's a reflection. That's a reflection. In what?
In the vector.
Nope. What's this thing? What's
oh,
this?
In the line.
What's the name of this line?
Would that just be the origin?
That's the y-axis.
Reflection in the y-axis.
Yep. It'll come together at the end, I promise. Let's see. The f of x equals 5 or the f of x equals minus 7. We transform it to be, so that's our original. It's transformed into y equals, from y equals the f of x to y equals minus the f of x. Minus the f of x equals 5. And minus the f of x is minus 7. Solve for the f of x each time.
So would it be minus 5 and 7?
Yeah. Y equals the f of x. So if we were to sketch it, 5 became minus 5, 7 became, sorry, minus 7 became 7. What type of transformation is that?
Reflection in the x-axis.
Well done. That's a reflection in the x-axis. We continue our backwards thing. When we were doing the vectors, if we did x plus 3, it's the vector minus 3, if and vice versa.
Yeah.
And in this one, if x becomes minus x, it's a reflection in the y-axis. If y becomes minus y, it's a reflection in the x-axis.
Okay.
And y equals the f of x. And so if f of x becomes negative, then that's a reflection in the x-axis.
Yeah.
Okay, how do we do this?
So that's a reflection in the y-axis.
Nope. That would be if it was in the bracket next to the x.
So would it go from minus 1 through 90 down through 270?
Yeah. That's a reflection in the x-axis.
Yeah.
Let's say. And if you think about it, if you were to rearrange this, so y equals cos x is the original one. If we were to rearrange this, like times both sides by minus 1, it would become that.
Yeah.
And so y became minus y, so it's a reflection in the x-axis.
Yeah.
So what else was I going to say there? They already brought it to the other side. Oh, it's gone. How would you describe the transformation? Describe the transformation A part 1.
Okay. So is it a reflection in the y-axis?
So what would be this coordinate, this point minus 1, minus 4, after this transformation? This is y is equal to the f of x. Where would it be after y equals, in y equals minus the f of x?
Would it be positive minus 4? Well, positive 4.
And so full coordinate?
Minus 1 comma 4.
Yeah.
All right.
Yep. How about part 2?
Would it be the new coordinate be 1 comma minus 4?
Well done. And describe the transformation in part 2.
It reflects in the y-axis, giving the coordinate 1 comma minus 4.
Yeah. So that is the coordinate of the minimum, but I just picked that. You could pick any. You could pick that coordinate, that coordinate. It's a reflection in the y-axis. The other is because it's in the bracket next to the x.
Yeah.
The other one is outside the bracket, and so it affects the y direction, so it's a reflection in the x. All backwards, all confusing. I always think there's. I was going to say something. I keep forgetting. Oh well. Let's see. You got. Oh yeah, that's what I was going to say. So if it's adding or subtracting, it's a translation. If it's a change, if it's a change of sign, it's a reflection.
Okay.
No. Yep. X equals 15. Or x equals minus 6. Those are our originals. New one is 3x. F of 3x.
That's 45.
Sure isn't. It's all backwards, remember?
5 for the first one.
Yeah. X equals 5 or?
X equals -2.
And so it was y equals the f of x. It became y equals the f of 3x. Describe that. What does that do to your answers?
It multiplies it by 3.
Sure doesn't.
Oh, it divides it by 3.
Yes, it's like times a third. Or divide by 3 because I had to bring it to the other side. Let's say times a third.
Yeah.
Okay. Let us now do y equals the f of a half x. It was x equals 15. It's now a half x equals 15.
So it'd be 30.
And the other one?
-12.
Equal -12. Describe this one. What did that do?
Multiplies your answer by 2. Doubles it.
Yes. So the f of 3x is times 1 over 3. The f of a half x is all the x's times 2. 2 over 1.
Yeah.
And so it's always the reciprocal to the x's. However, let's see, this one down here. All right, with the y's, they brought it to the other side already. And so it will just be the same thing. It won't be, so here it's the opposite. If they already brought it to the other side, then it's just what it is. So if it's like 3 the f of x times the y's by 3. The graph used to look like that.
Yeah.
I might come back to this. Now I'll come back to this. Yeah, how do we do this?
Would you divide the graph by 2? Because it's cos divided by 2.
It's already been brought to the other side.
So you'd multiply it by 2.
Multiply what by 2?
Like the distance, like the x, like the x-axis. So it'd be like 180 to 360.
That you're thinking of if it was in the bracket next to the x.
So would the height double?
Yeah, it's outside the bracket, and so that's like that. Describe the transformation.
The y-axis is doubled. I'll multiply by 2.
If it's times a number, it's a stretch.
Okay.
Which direction was it? X or Y?
The y-axis.
Y direction. Scale factor?
Of 2.
Yeah. Okay. So describe each of these. Hang on. Describe. What will be part B? Describe that transformation.
Scale factor of 3.
Yeah.
Is it stretched or is it not?
It's a stretch because it's times by a number.
So it's stretched and it's in the x direction.
That would be if it's in the bracket next to the x.
The y direction.
Yeah. It's all confusing. Even if you understand it, you can easily make a mistake with these. Describe these two.
Is this not stretched, would you say?
It's times by a number.
So it's stretched?
Yep.
By a scale factor of 2?
No.
A half?
Yep.
And it's in the x direction.
Yep. Part B.
It's stretched by a scale factor of 4.
Definitely not. Reciprocal of 1 over 3.
Oh, 3.
Yeah, 3 over 1, 3. Direction.
X-axis. X direction.
X direction. Okay. Doing great. Doing great. We'll get there. We'll get there. We'll get there. Now, so it might be time to jump back. Compound. I'm not going to do compound if I can avoid it. Maybe if I have to. Okay, how about these two?
So would it be stretch?
Yep.
Scale factor of 2.
Yep.
In the y-axis. Y
Right.
direction.
Yep. And so this one down here?
Stretch by a scale factor of 3.
Oh.
Oh wait, no, a third.
Yep.
In the x direction.
Yep. And so where does the point, where's the new maximum?
So would you multiply 5 by 2?
Yep.
Which gives you 310.
And this one?
That would give you 15.
Great. You're there, my man. You're there. You're there. You're there. Which makes me happy. I don't have to look at this thing anymore. Let's see. You'll be fine. So let me now jump back. Let me jump back. Okay, exam time. Part B.
So for this, would you say it's stretched?
Yep.
Would you say by a scale factor of 2?
Yep. No.
Half.
Yep.
So if it's on the left, it's by 2, but if it's on the right, it's by a half.
Basically, if it's next to the letter, then it's the reciprocal. It's going to be the opposite. It's just because they always put it as y equals. Like if they put it as a half y, if they put it as 2y.
Yeah.
2y equals cos x. That would be a stretch y direction scale factor a half.
Yeah.
But they always bring it to the other side. So they always write it as y equals a half cos x. And so it's, it's still a stretch y direction scale factor a half. But it's because they bring the y one to the other side that it's what it looks like. Whereas with the x one, it's the opposite.
Yeah.
Yeah, it's only because they rearrange it. Okay. Which direction is this one in?
Is it in the x-axis direction?
Yep. Any idea about C? What that's about?
Isn't that to do with like when it goes down and then up? That's one period.
Yeah. So when it fully repeats. Do you know what that is for cos?
Is it cos 4?
360.
Okay.
And so y equals cos 2x. What's going to be the period for that one?
720.
Scale factor a half.
180.
Yep. Write down the values of x for which cos 2x is equal to 0 in this interval. Oh, I don't like it. They're gonna let me come. This is a solving equation thing. I'll probably just
Yeah.
deal with that when it comes time to solving equations. Yeah. Okay, how about B?
So it's a reflection.
That would.
No, it's the translation.
Yep.
Translation of 20(0).
Well done. Great. That's great. The coordinates of points where the curve crosses the x-axis. Okay, it's interesting. How about part A?
Okay. So be 0. Wait, no. It would be minus 300, 0. Minus 120, 0. Uh, 60, 0. And then 240, 0.
Hope so. Yep, there we go. Okay, let's try B.
Okay. So it's a stretch.
Yep.
Scale factor of 5.
Yep.
And it's reflected in the y-axis.
Not reflected, just.
Oh, sorry. Directional. Direction in the y-axis.
Y direction.
Yeah.
No axis. C.
Would the maximum be 5?
Yep.
And the minimum be minus 5?
Yep. Let's see. Not doing that yet. What's this thing? The graph shows the curve with equation y equals sine x plus k. Okay. What would be k?
Don't know.
Sine graph. What is it? A sine graph usually looks like that.
Yeah.
Or whatever. So it usually crosses at 180.
Yeah.
It's now crossing at 120.
Okay.
And so what k would change it from 180 to 120?
Oh. Okay. It'll be plus 60.
Yeah, k equals 60. B?
Can there be one more? Because, like, if the graph was in the reflection of the x-axis, could you use minus 60?
Let's see. minus 60 would move it 60 to the right. And so the one that's at 0, if it moved 60 to the right, then this would be like 60. There'll be that plus 60, that plus 60. And so that wouldn't go through 120.
So there is no possible answer.
There's infinite possible answers. So you said that 180 moved 60 to the left.
Yeah.
What if the previous one moved to the right? So see how it crosses at 0?
Wait, so you're saying if 0 moved to the right?
Yeah. How many to the right would I have to move? To give the graph that they have now.
120 degrees.
Yeah. And so what would be another possibility for k that would move the graph 180 to the right?
Minus 120.
Yeah. K equals minus 120. And what else is it saying? Give a reason. Is there more than one possible answer? Yeah, it's infinite. Graph could be translation right 300 as well. Yeah, you could do x minus 300. You could do all sorts of stuff.
Okay.
It's infinite. So you can keep spinning round and round and round. But I'm going to use a better... Yeah, fine. State the solutions. Find one possible value for k. I'm going to do better. Better than that. These... it's an easier way to do these. That's by solving. Okay, let's solve. Let's get our feet wet with this solving malarkey. Got to do it sometime. Hey, we're in chapter 9. Near the end of chapter 9, so got to do it sometime. Okay, this one up here. Question D. X is between 0 and 360. What is 2x between?
Would 2x be in between 0 and 720?
Yep. Okay. Make your life easy. Let 2x be equal to a, and so it becomes cos a equals 0.
Yeah.
Solve.
So we dividing by... Wait.
Opposite of cos is shift cos.
Oh.
Inverse cos.
So would a be cos, the inverse of cos?
Inverse cos of 0.
Yeah.
Calculator, baby.
I got 90.
Okay, so one possible solution. A is 90 degrees.
Yep.
How do you get additional solution for cos? Do you remember? I'm not sure if we did it.
No, I don't remember.
Cos theta is equal to cos 360 minus theta.
Okay.
And so it is 360 minus your first answer.
So it would be cos 90 equals cos 360 minus 90.
Yeah, and you can cancel out the causes, and so it's just 360 minus 90.
Which is 270.
270. Okay, how can we get additional solutions, do you know?
Could you minus 90 from 270?
You can add 360 to both of those answers.
Oh. So 90 plus 360 is 450. Would that be an answer?
Yeah.
And then 270 plus 360 gives you 630.
Okay, and so we get 90, 270, 540, was it?
Yeah,
And what was the other one?
630.
630. Okay. So that's what A is equal to, which was 2 theta. So what would 1 theta be equal to?
Half of them.
Yep.
So 45. 135. And then 350.
I think so. Do I have the answer? 40, yeah. Okay, so just, okay. Let's see. Let's check our answer. Cos of 2x equals 0. Cos of 2 times 90. Does it equal 0? No, it was 45, wasn't it?
Yeah.
45, yes. Another one was 270. Yes. No, it was 135.
Yeah.
What you can also do is, let's just say cos 90. That was 0. Cos 90 plus 360. You spin 360 around, back where you started.
Yeah.
Spin 360 around, back where you started. And so, let's say we spin 361. Nope. And so, cos theta is equal to cos 360 minus theta. That gets you, so first answer is shift cos both sides. Second answer is 360 minus. Any and all additional answers you can add or subtract 360 as is needed.
Yeah.
Let's see. Maybe. No. These are actually... alright, let's give this a go. Let's see. Let's just do... No. Alright. So these actually start off not too bad. Maybe I getting ahead of myself a bit. I'm getting ahead of myself a bit. But let's just do question C.
So it'd be 20 and... Would it be 20?
Hold on. So let's change the interval first. So x is between 0 and 360.
Yeah. So would it be... X is... Would it be 2x? Or x minus 20?
What is that between?
Would it be 20?
How would you go from x to x minus 20?
Or you'd minus 20?
Mm-hmm.
So it'd be between minus 20 and 340.
Yeah. Okay. Let x minus 20 be equal to a. What would you get?
Would you still get minus 20 and 340?
X minus 20 is a. Sine a equals 1. A is between minus 20 and 340. So it just takes two different things, turns them into just one thing. Sine a equals 1. What is a? How do you solve it?
Would you do inverse sine?
Yep.
So would you do inverse sine and then the number?
Yep.
Or 1?
Yep.
So inverse. It gives you 90.
Okay. Do you know how to find second solution with sine?
Does it go up to 180, right?
Yeah, sine theta is equal to sine 180 minus theta.
So it'd be 90 minus 180, 180 minus 90.
Yeah, what's that?
which gives you 90.
Ah, okay. How do we get extra answers then?
And then we do. So we got is two of the answers 90 and 90.
Yeah, so it's just one repeated answer then.
So can you add 180 to both of them?
It doesn't repeat every 180. How often does sine graph repeat?
360.
Yep.
Which gives you 450. So you have 90, 90, 450, 450. Is that right?
In theory, yes. In practice, 90 is just a repeated solution, so you just need
Okay.
90. Secondly, our range is only between minus 20 and 340. What is 90 minus 360?
Minus 270.
And so that's outside the range. And so there's only one solution. A is 90 degrees, but we don't want A, we want theta. We let theta be equal. We let x minus 20 be equal to A. So now unlet it back again.
Would you plus 20 to both sides?
Yep.
Which would give you 110 degrees. X is 110 degrees.
I sure hope so. 110. Okay, same idea. Part last.
Okay. So, would it be 90 and 240 as well, but it's with minus 1 this time?
Follow the process. What did we do first?
We wrote down like the range in between.
Okay, so that's all the same actually. Yeah, so the range is still between minus 20 and 340.
Yeah.
What's next?
Would you let A equal the inverse of sine minus 1 this time?
No, you'd let x minus 20 be equal to A, same thing.
And then would you do, instead of inverse sine 1, would you do sine 1?
No. This time, so sine A is equal to minus 1. Because we let that be equal to A. So that's what you'd solve.
So would you do divide by inverse sine like what you wrote there?
Yep.
And would that just give you A equals sine 1 minus 1 1?
Mm-hmm.
Which gives you minus 90.
Minus 90. Okay. And so, how do we get second solution?
We do 360 minus 90?
It wasn't 360. What was it?
Oh, 180, sorry.
Yep.
Minus 90. That gives you 270.
So that's 270. Can we get additional solutions by adding or subtracting 360 to these? Our range was minus 20 to 340.
So we could do minus 90, add 360.
Yeah.
Minus 90. Which gives you 270 as well.
So that's a repeated solution. 270 Subtract 360 is minus 90. So it's just one solution. Okay. We don't want A, we want X.
So we write it as x minus 20 degrees equals 270. So you'd plus 20 on both sides, which gives you x equals 290.
X equals 290. X equals 290. Boom. Okay. We got it.
Yeah.
We got it. So yeah, what do you give yourself for those ones?
Probably between a tick and a half.
So solving trig graphs is, I think it's as hard as it gets. But anyway,
Okay.
how is that for you, Adam?
That was good.
So we finished chapter 9, and so chapter 10 next time.
Yep.
Any questions for me in general?
No.
All right, well done, Adam. You did great.
Thank you.
And yeah, I look forward to talking again next time.
You too. Bye.
Take care. Goodbye.